Okay, we're going to talk about reflection. Reflection is when waves bounce off of a barrier, and we're going to talk about how the waves will do that. We have several different animations that we're going to use to kind of demonstrate that. The first one kind of looks like this. Let's see, I can zoom in here, I think. And so we have waves coming in here. Now remember, if you remember rectilinear propagation, this is the direction that the waves are propagating, and then these are the wave fronts, and they're perpendicular to the direction that they're propagating here. We have what was called a law of reflection. It's a pretty easy law. It says that, so if this is the incident ray here, and this is the reflected ray here, it says that the angle of incidence, which is this one right here, kind of alpha is the way it's labeled there, incident, that is equal to the angle of reflectance, the reflected angle, okay? So, and that's actually a law. Angle I equals angle R. It's a very easy law. Now, of course, this angle here and this angle here would also be equal, but those are not the angles that we are used in this law. It's always the angle between the ray of light and what this line right here. And this line right here, of course, is called the normal line. Its normal is perpendicular to the surface. So we're always measuring the angle from the ray of light to the normal. So this is the angle of incidence, this is the angle of reflectance, and those are equal. So that's the law of reflection. It's a pretty easy law, and that's how those things kind of bounce off of each other. Okay, let's do another. Let's do concave reflection. Concave reflection. We see a straight wave going into this concave barrier. And you'll see it comes in here and then it kind of bounces and it kind of goes down, it collapses down to a single point, and then it expands back outwards again. Okay? And so what's happening here is you had a straight wave, and it was, I could draw one part of it was coming in like this, and then right here there's technically a normal line, right? So the angle of reflection still occurs. So this angle I is equal to this angle R, and this thing bounces off like this. If something comes in straight along this line, it's going to bounce straight back. And then if one comes in like right here and goes up like this, I could draw a normal line in here, and the angle I would equal the angle R. So the law of reflection still applies, even though these reflected rays aren't parallel to each other. They're all coming into the exact same point right here, which is actually called the focal point. This is like an ellipse, and this is the focal point. That's why it's called a focal point. All these things focus on it, and then they'll go on through, right? So I didn't do that very good. There's my focal point. Okay, and they'll go on through, and it'll be an expanding circle wave that actually goes on out. This concave reflection, kind of interesting. And then we could have, let's do our next one. We got a convex reflection. So here they're coming into an outer thing, and again we have the same situation. They're going to come in. This will come in like this, and it's going to bounce off like this. And there again is a normal line, and so angle I equals angle R. And this one's coming straight along the normal, so it's going to bounce straight back out. This is going to come like this, and it's going to bounce out this way. And you're going to get basically circular waves that come out, basically the same shape as this one right here. We'll just let them continue on, boom, like that. Okay, so that's convex waves. All right, let's see here. Next, we're going to do fixed end reflection. Fixed end reflection. So what's happening here is interesting. If we have a like a rope or a slinky or something, and we send a wave down it, but the end is clamped on. It's like attached. It's called what we call a fixed end. It's not allowed to move the medium there on the end. It's fixed. And what happens when you have a fixed end and when you have a wave come into a fixed end, it'll reflect and go back the other way, but it'll reflect what we call 180 degrees out of phase, or just completely out of phase. So it comes in as a crest. It goes back as a trough. Comes in as a crest, goes back as a trough. So fixed end reflection is 180 degrees out of phase. It comes in this way, and then it's going to reflect down around this way and go back that way. It comes in this way, reflects 180 degrees out that way. Okay, I want to kind of show this on something else. We have this little device here, and I can make different waves down here. And this is fixed in, it's clamped on here. So if I do that, and I just do one little pulse right down there, it goes down and it goes around 180 degrees. And see, now it comes back here and it's fixed here again on this end. And so it'll actually go back around and do that thing over and over again, like that. Okay? I can do this kind of manually too. I can just grab it and just go. Okay, and there it goes. It reflects 180 degrees if it's fixed, if it's a fixed end. Okay, so let's just kind of keep that in mind, and we'll come back and look at that here in a little bit. Let's look at a free end reflection. There we go, a free end reflection. Okay, so now a free end, what we have is we have this little ring here that's on this kind of pole here. It's frictionless, we're going to say. And so it's not fixed, it's allowed to actually go up. So when it comes up, it goes up and then it falls back down and it sends a crest right back out the same way that it came in. Okay, so this is a free end reflection. And free end reflection means 0 degrees phase change, 0 degree phase change. It's going to come in as a crest, it's going to go back as a crest. So fixed end was 180 degree phase change for reflecting. Free end is 0 degree phase change for reflecting. So that's important that you're taking notes on these and remembering all that. Let's look at this on here again. So we do a free end, a loose end right there, and I can do a little wave down here, and it comes back on the same side. Now notice when it comes back here, this is fixed again, so it's 180 degrees when it gets to the wrench, right? But on the end, it comes back the same way it goes in. So it comes in as a crest, goes back as a crest. But here it flips to a trough, back as a trough. Flips to a crest, back on a crest, right? So it's a free end over here, and it's a fixed end over here. Let's do that with a pulse. There it goes, okay? And see, it goes back around because this is a fixed end over here, free end over here. Okay, good. By the way, we can do no end also, and we can just do waves, and they go out the window and they don't come back. So we could do oscillate. So we send a whole bunch of waves that are going out that way. That's nice. Okay. All right. Let's go. What do we got next? Okay. Fixed end and free end. Okay, so now what we're going to do is we're going to do something a little trickier here. We're gonna go to a low impedance to a high impedance and see what this means here. Okay, so I'm gonna freeze that here for a second. So what we have here, let's see. I'm gonna unfreeze that here a little bit. I'm gonna kind of blow this up here a little bit. Okay. What we have is we have two different mediums here. We have two different mediums. This is like this first one is like I don't know, like a string. It has low impedance is what we're going to call it. Impedance. Impedance, if you look in your book on the bottom of page 72, there's a really big definition there for it. It says the impedance of a medium is the ratio of the wave-producing force to the displacement velocity. Really what that means is how hard is it for a wave to go through it, right? So if it's impedance, right? So if it's really difficult for a wave to go through it and it impedes the flow of the wave, it has high impedance. So this string we would say would have low impedance, but it goes into a big heavy rope and it would have high a high impedance. Okay, so what we want to do is we want to figure out what happens to a wave as it's coming along this string here. It's going this way, and what happens when it hits this boundary between the low impedance and the high impedance? What will happen? Well, some of the wave is going to go ahead and go on through. Some of the energy is going to keep going through into the rope. But whenever you have a barrier, a boundary between different impedances, reflectance will always happen. So you're going to have some reflection at this barrier. Now, how is this wave? This comes in as a crest. How is it going to reflect when it gets here? That's the key. Okay? Some of it's going to still keep on going, right? Now, the wave's going to travel slower when it goes into the rope because it has higher impedance, so it's going to travel slower. And if it travels slower, that's a different medium. It travels slower. The frequency's staying the same. But if it goes into this higher impedance, the velocity is going to go down, so the wavelength would actually have to go down on the wave. But what happens right here at this barrier? What kind of reflectance occurs at this barrier? And so if we watch this happen, here it comes. We're going to do it. Here it comes, and you'll notice it came back at 180 degrees, right? So it came in on the top, but then it reflected back as a trough. Okay, now why was that? That's because it was going from a low impedance into a high impedance. That's very similar to going into a fixed end. Remember, a fixed end, you had a 180 degree reflection. Now this isn't actually a fixed end. A fixed end means basically an infinite high impedance, right? It's not allowed to even go into the next medium. Here, this is not an infinitely high impedance. This has a high impedance, so some of the energy can go on in, but some of it's going to be reflected. But it's very similar to a fixed end in that it's going to reflect at 180 degrees out of phase. So the key to remember here is low to high, goes low to high, you're going to have 180 degree reflectance. Okay, low to high, 180 degree reflection. All right. Let's look at then going from high to low. Here's high to low. What happens? Well, some of the wave continues on, right? It continues on going. But what kind of reflection happens here? It's in phase. See how it comes in as a crest and blow it up here a little bit. Comes in as a crest and goes back as a crest. So this is going from a high to a low, and so therefore it's going to this is going from a high to a low. Okay, and so the reflectance is going to be 0 degrees. 0 degrees. It's going to come in as a crest. It's going to go back as a crest. Now when it comes into this new medium, it obviously speeds up. It goes a lot faster, right? So the wavelength actually will get longer, right? It'll get longer, okay? But the frequency still stays the same, okay? You're not changing the frequency. If you go to a new medium, you can change the velocity, but you're not gonna change the wavelength, but you're not gonna change the frequency. Okay. I think that's pretty much all we need for reflectance. That's like the entire page 72 if you looked at that, and I think that's probably good enough.